Now that we've talked about Earth's motions and how we not only rotate and revolve around the sun, we now need to talk about our moon. And our moon's formation or origin comes from the giant impact hypothesis. That's a object about the size of Mars struck Earth during its formation and ejected debris out into space. That debris began to orbit Earth because of the gravitational attraction between the two objects, and eventually it clumped together, forming what we now call our moon. The moon's motion is much like that of Earth around the sun. The moon orbits Earth in an elliptical pattern. It has a point where it is closest to Earth, and we call that perigee, much like perihelion when the Earth is closest to the sun, and apogee, which is the point when the moon is furthest from Earth, and it's very similar to aphelion, with the point when the Earth is furthest from the sun. Because the moon's period of rotation is the same as its period of revolution, we only see one side of the moon. So because we only see one side of the moon, we do see different phases of it, because the amount of sunlight that is being reflected off the moon will always be half lit. We don't always see the half that is lit, however. So when the moon is between the sun and Earth, we don't see any of it lit. If you look at the diagram on the right, you can see the inner moons surrounding Earth show you that it is always half lit, and then the outer moon show you what we see when or what the moon looks like in the sky at that point in time, depending on its location around Earth. So when it's between the sun and Earth, we don't see any of the lit half, we only see the dark half, and we call that a new moon. Then as the reflective side starts to show, we see the right half of it lit. Anytime you see the right half of the moon lit, you know that the moon is growing in its reflective size. So we call that waxing, and the first phase after a new moon is called waxing crescent. Then we reach the first quarter. We see a quarter of the moon that is lit, or half of the lit half. Then you'll see in the upper left corner a waxing gibbous. Anytime that more than half of the moon, or half of the visible side of the moon, is lit, we call that a gibbous. And then eventually, when the moon gets to the other side of Earth from the sun, we see the entire thing lit in the sky, and we call that a full moon. The only thing that you need to do to remember the phases as the moon gets smaller in size, at least from our perspective as we look at it in the sky, is change waxing to waning, and then reverse the order of the phases. So we go from a full moon to waning gibbous, to then third quarter, then waning crescent, and then we start all over again. So again, anytime the right half of the moon is lit, we know that it is growing in size, at least to how we view it when we look at it in the sky. And then anytime the left half is, or the left side of it is lit, we know that it is getting smaller in size, or approaching another new moon by our standards of the way we look at the moon and identify its phases. The reason that we do see the moon at all times is because the moon's plane is at a different degree than Earth's plane orbiting the sun. So just because the moon is between Earth and the sun doesn't mean that it is going to give us a solar eclipse that you see here. A solar eclipse is only going to happen when the moon, the Earth, and the sun all line up on the same plane, and the moon casts a shadow onto Earth's surface. The same thing holds true for a lunar eclipse, and that's when the moon passes through Earth's shadow. The lunar eclipse lasts much longer because Earth's so much more massive than the moon itself, and so these last about 4 hours as opposed to only a few minutes. The next lunar eclipse that we are going to experience is going to happen on October 8th, 2014, and the next solar eclipse is going to happen until 2017. Another interaction between the moon and Earth is the moon's gravitational pull on Earth is the reason that we experience tides, both high and low. You'll see in the diagram at the very top spring tide, and that's when the moon is either between the Earth and the Sun or on the opposite side of the Earth and the Sun, versus a neap tide when the moon is making a right angle with Earth and the Sun. And what the moon's gravitational force does is it pulls on the water in the ocean so that there are bulges on both sides of the planet. The moon pulls the water towards it, causes the bulge towards the moon, as well as creates a bulge on the other side of Earth. And the reason that it creates the bulge on the other side of Earth, or another high tide on the opposite side of Earth, is because it is pulling Earth away from the water on that side. So anytime you see the moon directly overhead, or the moon is on the complete opposite side of the planet, is when you're going to experience high tide. And the same thing holds true to when the moon is at a right angle to where your location on Earth is. You are going to experience low tides. On average, we experience 2 highs and 2 low tides per day, and that is just due to Earth's rotation as well as the moon's revolution around Earth itself.